Here's another question from a student. Express the rational expression as a single line expression. This is rationalizing the denominator, really. If we are going to express it that way, then we have to rationalize the denominator. And the method to do that is to multiply and divide by the conjugate of the denominator, okay? So, given an expression, if you're given a plus b as a binomial expression, then a minus b is called the conjugate of a plus b. So if I'm given a minus b, then a plus b is the conjugate. So these two expressions are conjugates of one another. Okay? I'm going to use that idea to solve this problem. So we have that 2 root of 5 plus 5 root of 2. We want to divide this by, we are dividing that by 2 root 5, 2 root 5 minus 5 root 2 minus 5 square root of 2. If I'm going to simplify that, as I've said, what we need to do is to rationalize the denominator. In other words, turn the denominator to a rational number. The square root of 5, the square root of 2 make this an irrational number. So I'm going to just multiply by the conjugate of that denominator. So the conjugate of this denominator is 2 root 5. This is minus, so the conjugate is plus 5 root of 2. And so do the same. 2 root 5 plus 5 root of 2. Notice that I'm multiplying and dividing by the same thing. This is equivalent to 1 because that divided by that is 1. So effectively, I'm not changing the value of my expression. So if I expand this, I get 2 root 5 times 2 root 5 is 2 times 2 is 4, and root 5 times root 5 is 5. So 4 times 5 is 20. So 20. This times this is 20. Then this multiplied by 5 root 2 is going to give me 10 root 10. I hope you can see that. I think I can write it down. So this is 2 root 5 times 5 root 2. And then I multiply this one out. This is plus 5 root 2 times 2 root 5. And this multiplied by that gives me plus 5 root 5 root 2, sorry. So it is 5 root 2 times 5 root 2 in the numerator, and the denominator becomes, so this is the reason we are doing this. If I have given a plus b times a minus b, if I multiply these two, in short, my answer is just going to be a squared minus b squared. Okay? This is the reason why we have decided to multiply by the conjugate of the denominator. So I want to use this trick to simplify the denominator much faster than what we are doing there in the numerator. And so what happens? We end up with, and this is what we do every time. And so all I need is that squared, which is going to be 4 times 5, 4 times 5, because 2 root 5 squared, 2 root 5 squared, and we're going to say minus 5 root 2 squared, according to what we've said there. So the numerator now simplifies to 20. And this is 10 root 10, and that's another 10 root 10. So we have 10 root 10 plus 10 root 10 plus 5 times 5 is 25 times 2 is 50, so that is 50. But the denominator is much simpler now. This is 20 minus, this becomes 5 squared times that, which is 50. Okay, and so my answer becomes 70 plus 20 root 10 everything divided by negative 30. And so my final answer can be expressed as negative 70 over 30, or negative 7 over 3, because we can get rid of we can get rid of the zeros. So if I divide, I get negative 7 over 3, and that becomes minus 2 over 3 root of 10. So clearly, based on that, Q is minus 7 over 3, and R is minus 2 over 3, and S is 10. Okay, and that's how we solve this question. And what the only trick we've used here is the conjugate pair. So if I multiply and divide by the conjugate of the denominator, it causes the denominator to, we get rid of the square root signs in the denominator, which makes life much, much easier. Okay? All right, we will look at the next question.